question 19, and I think you may have written it out yesterday. And the question was to find the equation of the locus of a point that moves so that its distance from the line 3x plus 4y plus 5 equals 0 is always 4 units. So what we did yesterday, we wrote this question out, and I quickly sketched that line 3x plus 4y plus 5 equals 0 with just the x and y intercepts. The locus of the point that is always 4 units from this line here, you could have a line that's 4 units up from here. So the perpendicular distance from this line to this line would be 4 units. The perpendicular distance from this line here up to that one is 4 units, or the perpendicular distance from this line here to this line down there is always 4 units. Look, you don't have to sketch it, but I'm sketching it so that you might understand what the question's about. We've got a line here, and I want to know the locus of a point that moves so that its distance from this line, where the pen is always 4 units. So the line could be up here, 4 units up that way, and 4 units down that way. Now, when we talk about distance of a point to a line, what formula is that? Perpendicular distance from a point to a line. So with this question, we use the perpendicular distance formula. Distance of a point to a line is always the perpendicular distance of a point to a line. So what we will use is this formula, D equals AX1 plus BY1 plus C1, absolute value of that, all over the square root of A squared plus B squared. That's the formula that gets used for this. Other questions use distance formula, but if we're talking about the distance of a point to a line, it's perpendicular distance of the point to the line. Girls, we looked at this formula, perpendicular distance of a point. I know you're getting confused because you're saying that's the distance from the line to the line, but we might have point P here, but point P might move down here, and then there'll be point P down here. So point P moves. But the important thing about point P is that it's always 4 units from the first line. Okay? So, D, what's the perpendicular distance of the point to the line? All right, so your point, this is what we've got. D is 4. The point is P, comma, bracket, XY. So, do you know what goes in up here? AX1 plus BY1 plus C1. What's that? It's the line. Okay, I don't know what the point is, but my line, so my formula gets set up like this. 4 equals absolute value of 3x plus 4y plus 5 over, do you remember what the a squared and b squared are? This is the line ax1 plus by1 plus c, or it's the line ax plus by plus c equals 0. That's what that line is, okay? The point is the point P, X, Y. So, do you know what A squared and B squared will be then? 3 squared plus 4 squared. So the point, you don't know what the point is. It's P bracket X comma Y. Normally the point gets substituted into this XY value. That's why it's normally X1, Y1 in the formula. But our point is just XY. So XY goes in there, and it's basically you're writing this line because you go 3 times x plus 4 times y plus 5. That's the line. The distance is 4 units from that line. No? Okay. So what have we got here? 4 equals absolute value of 3x plus 4y plus 5 over the square root of 25, which is 5. So therefore 20 equals 3x plus 4y plus 5. Absolute value. Now, if you've got absolute value of that equals 20, you end up with 2 scenarios. So therefore your 2 lines are, so doesn't this mean that 3x plus 4y plus 5 equals 20, positive 20, or 3x plus 4y plus 5 equals negative 20? Now, with equals positive 20, I'm just going to take the 20 over to the other side to get the equation of a line. So what do I get here? 3x plus 4y minus 15 equals 0. That's my first line. And 3x plus 4y plus 25 is 0. Now that's my second line. So that's line 1 and that's my second line. Now, those are my answers. Wait a sec. Do you know that when you see parallel lines, that they look exactly the same? So if you look at the three lines now, I've got 3x plus 4y plus 5, 3x plus 4y minus 15, 3x plus 4y plus 25. Those three lines are parallel. And those three lines are these three lines. Now, if you really want to know the position of those lines, I could put them to prove to you that they're all parallel. I can put them all into y equals mx plus b form, and you'll see, you know they're all going to be the same gradient, because when I make y the subject of each of these formulas, I'm going to get -3/4 for my gradient. Because if I go 4y is minus 3x minus 25, then I divide by 4, all the gradients of these three lines, of this line up here in the question, line 1 here and line 2, the gradients of all those lines are the same. Now, I'm going to rearrange those lines, okay? I'm just going to draw out the answer so that you can see that our answer is correct. So, I'm going to look at the first line. The first line was 3x plus 4y plus 5 is 0. That was our original line in the question. If I rearrange that and make y the subject, don't I get, let's take the 3x over and the 5 over, and then wouldn't I have to divide by 4? I would get this. That's the original line, right? Now, isn't that a line with gradient, -3/4, y-intercept -5/4? That's this line here drawn, the original line. If I look at line 1 that was in our answer, 3x plus 4y minus 15 equals 0, and I make y the subject of that one, what do I get? Minus 3x plus 15, but then don't I have to divide by 4? That's line 1 in my answer. Wait, I'll just move it. No, I want to show you. I'm trying to show you how this all works. So the first line, the original line had a gradient of -3/4, y-intercept was -5/4. Let's say it looks like this. That's the original line, original. The next line's got a same gradient. Y-intercept is 15/4, which is nearly 4. It's 3 3/4. Second line might look like this. Right, that's that second line, 3x plus 4y minus 15 equals 0. The third line, the other line that we got as part of our answer was 3x plus 4y plus 25 is 0, making y the subject. I'd get -3x minus 25, and I'd divide them both by 4. Well, 25/4 is 6 and a bit, minus 6 and something, roughly. It's down here. So the y-intercept of this one's minus 25/4. The y-intercept of this one's minus 5/4. Yep. The y-intercept of this other one is 15/4. Now, they're the three lines. They're all parallel, and the distance between the middle line and the other two lines is 4 units at all times. Do you see what this all means? You don't need to draw it. I'm drawing it so that you'll understand what the question's about.
If we didn't draw it, how would we know that we have to use the perpendicular?
Because you'll know that you have to use the perpendicular distance formula, because it says find the equation of the locus of a point that is always 4 units from this line. That is the distance of a point to a line. There is only one formula that gives you the distance of a point to a line, and that's the perpendicular distance formula. Gives you the distance of a point to a line. That's the only formula you can use. The problem is that point moves continuously, but that's why the point is called x comma y, because its value can always change. So would you say that this line here is always 4 units from that first line? And this line down here, I haven't drawn it very well, but it is always 4 units from that middle line, that original line. Okay? And that's how that question works. So if it says the distance of the point to the line is this many units, perpendicular distance of a point to a line. Ladies, we're now going to do question 26, I think was similar. No, I've got it up here. Well, you're going to miss out. I had it written down. All right, next. You got all that? Yes? You can look at the video if you need to copy that. Oh, it's question 23. Okay, now. Sorry, question 23, same exercise. Last one, I've actually got the answer there. I'll just cut it off and I'll do it again. One sec. The locus of a point that moves so that it is equidistant from those two lines, 3x plus 4y minus 5 equals 0, and 5x plus 12y minus 1 is 0. You want the locus of a point that moves so that the point is equidistant from the line. Point, distance of a point to a line. Which formula? Distance of a point to a line. Perpendicular distance. But you've got the perpendicular distance of your point to the first line is the same as the perpendicular distance of your point to this second line. So you're going to have to set up two formulas. Now I'm going to sketch these. With the first equation, 3x plus 4y minus 5 equals 0, I want the x-intercept. To find x-intercept, you put y equals 0, and what will you get if y is 0? Girls? If that bit there is 0, you get 3x minus 5 equals 0. You get 1 2/3, so I'll just put 5 on 3 roughly here. Also for this first line, if the x, to find the y-intercept, I put x is 0, so if this was 0, 5 on 4. I'm just doing a quick sketch, girls, so that you see what the question's about, all right? That's the first line. So this is the line 3x plus 4y minus 5 equals 0. Wait a sec, I'll just fix this up. The second line, y-intercept, put x equals 0, what do you get? I think you get 1/12. Very small. The second line, if you want x-intercept, you put y is 0, you'd get 1/5. Very small. Oh my goodness. All right, I think they're going to cross somewhere. It doesn't matter where they cross, but they will cross because they've got different gradients. See, girls, if lines have got different gradients, they will cross. Might be off the page somewhere, but they will cross. If two lines are not parallel, they will eventually cross somewhere. All right? So that was that line, and this other line is 5x plus 12y minus 1 equals 0. Now you have to find the equation of the locus of a point that moves so that it is equal distance from those two lines. Anyone want to take a guess what the two lines might look like? All right, just leave it. I'll tell you, yeah, there will be one through the middle. I need a different coloured pen. Your answers are going to look like this. This better not be. There's going to be one through here, I think. I think that line is always equal distance, and I think there's going to be one that goes this way, I believe. All right? But what I'll do, that's what I think. But let's work out what the equations are, and then we'll sketch them at the end to see if this is the case. All right? Okay. Using the information from the question, now you don't have to sketch it, but the reason we're sketching it and visualizing it is that you may end up with a harder problem where you might need to be able to visualize it to be able to interpret some solution of some sort. So it is a good idea to try and visualize it. So what would I do? That the distance, see what I've got is that the distance from the point to that first line equals, what's the question telling me? That the distance from that point P, X, Y equals the distance from P, X, Y to the other line. Isn't that what it's telling me?
Same thing as PA equals PB and then we square and then...
In a way, yes, but it's not the PA, it's the D. You've got to use the perpendicular distance. So for the first line, I've got D equals, isn't it, absolute value of 3x plus 4y minus 5 over the square root. Now, I don't know what the distance is. They don't tell me it's 4 units or anything. So the distance D equals the distance D from the point to that line. Do you know what I do with the first one? So I'm doing the first bit. Distance from the point, what do I do? It is. What do I put under here?
3
squared plus 4 squared, and I get 5 there, don't I? So I get D is absolute value of 3x plus 4y minus 5 over 5. Yep. And then my other line is D equals absolute value of
5x plus 12y
minus 1 over the square root of
5 squared
plus 12 squared. That's a Pythagorean triad. Very good. Over 13. Now, if the distance here equals that distance there, does this make sense? What do? You, yeah, so you solve simultaneously.
put the 5 there, like 5
Yep, no, I wouldn't, because then it, see, because, yeah, they're equal to each other because they're both D at the moment. So you say D equals that one and D equals this one. So now we put the 2 equal to each other. Now we're going back to term 1. When you've got this type, it's not 4 cases, girls. If you did plus plus on both sides, you know how you've got to try and do all the combinations? Plus plus, if you made these both positive, it's the same as making them both negative, because then you could swap sides. So you only need to do plus plus and a plus minus. One plus minus is the same as a minus plus, because you could then swap sides. So we only need 2 scenarios here with the double absolute values. You just need both positive, which is identical to both negative. Because if you put them both negative and you swap sides, they're now both positive. All right? So you only need 2 scenarios. So we've either got that, let's make them both positive, equals 5x plus 12y minus 1 over 13. We need to, or we've got both negative. Not both negative. One positive, one negative. It doesn't matter which way you go. Let's do the first one positive. And you know what? Instead of putting the negative on the top, because I've got to change the sign of everything, I'm going to put the negative on the bottom. Does that, because if a fraction's negative, the negative can go on the numerator or the denominator. I'm going to put it on the denominator because it doesn't matter actually. Look, it doesn't matter. Just put it up here. Put it there because, got it? All right. Over 13. Yeah, then we're going to cross multiply both. So let's solve these now. So cross multiplying, I'm going to do it straight away. 39x, 13 times 4, plus, is it 52y, minus 65 equals, cross multiplying, 25x plus 60y minus 5. Let's make the x's positive because in general form the ax has to be positive. So 39 minus 25 is, yep, 14x. Then it'll be minus 8y. And then bringing the minus 5 makes it 60 is 0. Now they're all even. So you've got to simplify and divide everything by 2. 7x minus 4y minus 30 is 0. Now there's no common factors there. That's your first line. And now your second line, we're going to cross multiply again. 39x plus minus 65 equals, now these are times negatives of all those. So what do you get? Negative 25x minus 60y, minus or plus? That's, yeah, plus 5. So bringing everything again over to the left to make the ax positive, what's 39 and 25? 64. 64x, bring that over, plus 112y minus 70. Are they all even? Divide them all by 2. 32x plus 56y minus 35. And they're your 2 equations. That's your answers. Because, girls, you're going to end up, you know how we thought we'd end up with 2 lines if I just go up to the... Whoops. I just took a photo. Wait. So, you know how we originally thought... Can I have a red pen or something, girls? Any colour. Anything that's not blue. So we thought we're going to end up with a line through here. Now that line will be... So girls, can you see the y-intercept of that line is between 1/12 and 5 on 4? Well, it's between the other two. Let's see. Let's play around with this first one and see what we get. I'm going to take the 4y to the other side. So wouldn't it be y equals 7 on 4x? If I take the minus 4y over there, I get plus 4y. And dividing by 4, I get minus 30 on 4. That's the first line. I reckon that's this one here. Positive gradient. All right, so the line's drawn pretty badly. I haven't drawn this to scale, all right? I could actually go into Desmos now and sketch them all, and you'll see it, okay? And this one, if I rearranged it, I'd get y equals negative 32 plus x plus 35, and I'd divide them both by 56. Okay, yes, I think that's this other line. See, 35 over 56, that's about a bit more than a half. That's that line there. And this other one, it would be this line here. So they're your two lines. So a point that moves so that it is equidistant from two other lines will be another two lines. Yeah. What I've done, you don't have to do this, what I've done in pink. I'm doing it so that you can see that these are two straight lines. One of them's got a negative gradient with a y-intercept that's less than 1, which would be that line there that I drew. And this line here has got a y-intercept of like nearly negative 8, which would be down here somewhere. And it's got a gradient of almost 2. So that's that other line there. Well, if I actually looked at any point from there to there, equal distance. From there to there. Because, girls, you would go from there to there. Equal distance. That's how you do it. From here to here. Equal distance. Okay? Girls? Okay. This is a homework problem. And Bernadette has kindly offered her book for us to see the solution to question 9. Question 9, the point PXY. So your point P moves so that it is equidistant from this point to -3 and this line y equals 7. So draw the point and draw the line first. Then you pick somewhere that, don't do it the exact straight line distance. Put it on a bit of an angle, put a point here. Then you need, when we talk about the distance of a point to a line, it must be the perpendicular distance. So you have to draw a line straight up there. So if this is xy, then this position, this point B up here has the same x value, which is x, across x up 7. So this point, the point B will always be some x value and 7. Let's say we're coming across here. It might be -4 and up to 7, like -4, 7, this point, or -3, 7, or -2, 7, 0, 7. The thing is, the x value of the point on this line will always change, but the y value will always be 7. So the important thing here is to get the coordinates of this point correct. And you can only do that by sketching. And once you've set up that diagram, you do the distance PA equals PB, and we go straight to PA squared equals PB squared, so we don't have to do square roots. All right? Is it okay now? Whoever had that problem, did you draw the diagram? This is Gloria's textbook. Thank you, Gloria. Exercise 11.3, circle as a locus. Yes. Can you write this out? The locus of a point P bracket x comma y that is always a constant distance from a fixed point is a circle. I think I made you write that out yesterday. But this is for a circle center 0, 0, radius r. So I want this first line copied out and this box here. We're not going to write the proof out. We'll just have a quick look at it. But can you just write down that first two lines, the first two lines and what's in the box? Hurry up, girls.
And then the proof.
No proof. Do not write out the proof. just write out these two and what's in the box. Copy this box down, please. The circle centre AB. We've been using HK, I think, but it doesn't matter. And radius R has that equation. Do not worry about the proof. Going to just look at these examples, but we're not going to copy them down because we're going to do different examples. Okay, the first one. It says find, ladies, girls, these aren't difficult. Find the equation of a locus of a point that is always 2 units from that point. If a point is a fixed distance to another point, you end up with a circle. So you have to know that this will be a circle with radius 2 and centre -1, 0. You have to know that. So then you just write up the equation that it's x minus a all squared plus y minus b squared is r squared. Then you sub in your centre and your radius, and that's your answer. Okay, don't copy it because we'll do some other examples from the book. Then this one is, you know how I was talking about completing the square? That's what we're doing today. So find the radius and coordinates of the centre of this circle. So girls, in this question, we're not going to copy this one down. We're going to do one in a minute, ladies, but you know it's a circle because it's got what and what in it? X squared and y squared. That makes it a circle. The plus 2x and the minus 6y means that the circle is not at 0, 0. Got it? So what we're going to do is we're going to learn and revise, sorry, not learn, we've done it before. We're going to remember how to convert that into, we're going to complete the square. What we're going to do here is we're going to be completing the square on the x squared plus 2x and completing the square on the y squared minus 6y. I'm not going to do it now because we're going to do some examples in the book. Okay? So you can just have a quick look at how they do it while I'm choosing some questions. Notice what they've done. They're trying to complete the square. We've got x squared plus 2x plus y squared minus 6y minus 15 equals 0. So this is what they've done. What they've done, they've taken the minus 15 over to make it plus 15 on this side. Then they've completed the square on the x squared plus 2x. Because you say, what's the b here is 2. Aren't you supposed to halve the b? And square it. So half of 2 is 1 and square it. So they're adding 1. Notice they've added 1 over here. And then they're halving the 6. Don't worry that it's negative because when you square it, it becomes positive. Half of 6 is 3. Square it, you get 9. So they're adding 9 to both sides. So therefore, these first 3 terms, x squared plus 2x plus 1, becomes the perfect square x plus 1 squared. And these 3 terms, y squared minus 6y plus 9, becomes the perfect square y minus 3 squared. And that equals 25 because you add these 3 things on this side. So you know how you're completing the square by adding 1? You add 1 to both sides. Complete the square by adding 9, you add 9 to both sides. So then you write it in the form x minus a squared plus y minus b squared is r squared. So we say, well, therefore, this is a circle with centre -1, 3, radius 5. Okay, so we're going to do some ourselves now. Okay?
Why is it positive square?
Because it's got to be in the form x minus something, y minus something. So the general form of a circle with centre AB, radius r, is x minus something squared plus y minus something squared. Because is that in the format of, because it's y minus, and that's the y value of the centre. If you compare it with x minus a squared, y minus b squared, the b is 3. And the a is -1. Okay, so it's -1, 3. Okay, I'm just going to choose a few questions now. Find the equation of the locus of a point moving so that it is root 2 units from another point. This will be a circle. So it'll be a circle. Therefore, this is a circle. Centre, 5, -2. Radius equal to root 2 units. So the formula for a circle is x minus a squared plus y minus b squared is r squared. So what's it going to be? X minus 5 squared plus y. Yeah, because it's y minus -2 squared equals square root of 2 squared is 2. Okay? That's your first question?
Already?
Yep. Oh, that's a quick
Oh,
one.
that's done.
Yep. Question 13, if you could start copying it down. Point 3, question 13. Find the coordinates of the centre and length of the radius of this circle. To do this, we must complete the square on both the x squared plus 8x terms and on the y squared minus 4y terms. So what we'll do first, does anyone remember what you do first? Yep, you bring the constant term over. Then you complete the square on the x squared plus 8x, and then we're going to complete the square on the y squared minus 4y. So what do we do to do that? We look at what, now I like to write it as plus 4 squared because you're dividing the 8 by 2 and you get 4, so you're adding 4 squared. The reason I like to do that, so I'm going to add 4 squared on this side. Then I go y squared minus 4y, I halve the 4 and it's 2 and I get 2 squared. So you know why I write it like that? Because this is much, you just go x plus 4 squared. Instead of writing the 16, you can see what this last term here is in the bracket. And that's why I like to write it like that. But this one will be a plus or a minus? Yeah, it's y minus 2 squared is. 4 squared 16. Instead of writing 16 here, I like to write it as 4 squared because you can see what goes into the bracket straight away. Now, over here you'll need to add 5 plus 16 plus 4 is 16. That's it. So therefore, what's the centre? Negative 4, 2, and the radius is 5 because that's 5 squared. Okay? Because 25 is 5 squared. Now we're going to move on and do some harder questions. We might just go straight to like,
21.
no, even harder, one sec. They won't be hard, but we need to do some of the more complicated ones. We're not going to just do all these questions. We're going to discuss them, then we're going to choose one to do. So, question 21, show that those questions are that those circles are concentric. You'd have to find the centre. Concentric circles. Yes, and they should have the same centre because I'm going to draw what concentric circles look like. So, girls, this is on recording. I'm drawing concentric circles. They're concentric circles. So these, if you want to write just somewhere in your notes, concentric circles have the same centre. So that's going to be for question 21. We're not doing it now, but do you know what you need to do for question 21? Okay. Show that these circles are concentric. In other words, show that these circles have the same centre. So what you will do is complete the square on both. So I'm not going to do question 21. We've discussed it, but it will be in your homework. Okay? Can I move now? All right. What about question 20? Prove that that line is a tangent to the circle. All right. We're doing this one. Girls, perpendicular distance of a tangent to a circle isn't the tangent perpendicular to the radius? So you're going to have, all right, we're going to, yes, you'd find the centre of the circle and the radius should be the same as the, girls, do you remember which exercise we were doing all this stuff? It was in the perpendicular distance. 8. It was in the perpendicular distance. What you're going to have to show, we're going to do this, you're going to have to find the centre. So for question 21, you're going to have to find the centre and radius of this circle. Now, sorry, question 20. The perpendicular distance. Now, just watch what I'm doing. I'm going to do it in a minute. Do you know what the question is? Prove that that line is a tangent to that circle. This is what we need to show. So question 20, this is the idea. Question 20, for your circle, if you find its centre and radius, that radius has to equal the perpendicular distance of the centre of the circle, which is the point to the line. So this is your line, 3x plus 4y plus 21 is 0. If that line is a tangent to that circle, it only touches it at one point. In other words, that the radius of the circle has to equal the perpendicular distance. So you'll be doing two sorts of things in this question. Okay, so what you'll be doing in this question is first find the centre and radius of the circle. Yeah, complete the square to do that. And then you'll use that the perpendicular distance, doesn't it have to equal the radius? Oh, then you do the perpendicular distance of the point to the line. And that distance that you end up getting has to equal the radius of your circle. You don't put the distance in. You'll put the line over a squared plus b squared, but the xy value that you substitute will be the center of the circle. Do you want me to do it? All right. Okay, let's do question 20. I might have to do some videos tonight on a couple of questions, all right? So exercise 11.3, question 20, prove that the line, you can do 21 on your own, that the line 3x plus 4y plus 21 equals 0. That's a 0. Prove that this line is a tangent to the circle x squared minus 8x plus, is this the same line we just did? No. I think it is. Plus y squared minus, it is. It's the same line. Oh. It's very similar. All right. Okay, so prove that that line is a tangent to that circle. Complete the square, let's go. X squared minus 8x plus y squared plus 4y equals 5. So let's complete the square now. 8x plus 4 squared plus y squared plus 4y plus 2 squared is 5 plus 4 squared is 16 and 2 squared is 4. So we get x minus 4 squared plus y plus 2 squared is 25. In other words, it's 5 squared. So therefore, this is circle, center, 4, negative 2, radius equals 5. So a quick sketch, center, down here somewhere, radius is 5. This is my circle. Okay? Now we've got to show that the line 3x plus 4y minus 21, I don't know how this, I don't know what it looks like, that it might go like this. So what I need to do, I don't know exactly where that line is, but I've just got to show that the perpendicular distance, girls, of this point, which is the center of the circle, to that line equals 5. So now, wait, I need some room. So I'll do it back up here. D is absolute value of 3x plus 4y plus 21 over square root of 3 squared plus 4 squared. But what was I supposed to substitute in for the x and the y? The point, 4 and negative 2. So we go 3 times 4 plus 4 times negative 2 plus 21 over the square root of 25 is 5. So I've got that. Now I'm going to move down here. And that's absolute value. So what do I get? D is 12 minus 8 is 4 plus 21. We get 25. Absolute value of 25 over 5. So what's that?
You've got to do 2 cases.
Distances are never negative. So it's 25 on 5, which is 5. Therefore, the perpendicular distance of the point of the center to that line equals the radius. Therefore, D equals R. Do we get it? Yeah. Perpendicular distance of the point to the line equals the radius. Therefore, the line is a tangent. You know, if the perpendicular distance is greater than the radius, it doesn't touch. Do you remember that? If the perpendicular distance is less than the radius, it cuts twice. Therefore, the line is a tangent to the circle. Now, your homework, or do you want me to put it in the video? Well, look, homework is exercise 11.3. I'll just do, just do question 1D, 2J, yep, 1D, 2J, oh, do 12. It's very quick. 1D, 2J, 12, I want you to do a circle such as, let's do 13I. Right, question 20 we just did. So 21 through to 28. But what I'll do, I'm going to look at 21 through to 28 and I'm going to choose. You'll also do 21 to 28, but I'm going to choose some from 22 to 28 to put in a video first. Okay? So you can attempt them, and if you've had troubles, look at the video. Okay.
So we don't say back?
No staying back.